Hello everyone, welcome to my class, Math Lesson with Miss Kenny. As you can see on your screen, I have put my lesson plan here. On our first meeting, which is today, we are going to learn about arithmetic sequences, and then linear function and the inverse of a linear function. On second meeting, you are going to learn about graph of a linear function. On third meeting, you are going to learn about geometric sequences, quadratic sequences, and cubic sequences. Let's start the lesson. What is a sequence? A sequence is a pattern. The pattern has certain rule, the pattern has certain order. In mathematics, we are going to use numbers. So sometimes we call it number pattern or number sequence. What about arithmetic sequences? An arithmetic sequence is a sequence which increases or decreases by a constant amount. We are going to use addition and subtraction to find the so-called common difference. Addition and subtraction are inverse operations. Remember, we are going to learn about inverse function here. In third meeting, you are going to learn about geometric sequences. Okay, we are going to skip this and save it for the third meeting. Multiplication and division are inverse operations. Yes, you are going to learn this for the inverse of a linear function. Next, this is an example of an arithmetic sequence. I put the numbers in ascending order, and I'm using comma to separate each number. So sequence is a list of numbers. Start from the leftmost number, 2. And then 5, 8, 11, 14. What number is going to come next in this sequence? Can you guess? It is the number 17. You need to look at two consecutive numbers. 2 and 5 are consecutive numbers. 5 and 8 are consecutive numbers. 8 and 11 are consecutive numbers. 11 and 14 are consecutive numbers. Between these two consecutive numbers, there is a common difference. 2 to become 5, you need to add 3. 5 to become 8, you need to add 3. 8 to become 11, you need to add 3. 11 to become 14, you need to add 3. So, what is the next number? The next number is 14 plus 3 is equal to 17. So, the rule here is add 3. The rule add 3 is the term-to-term rule. Term-to-term rule means between two consecutive terms. We are no longer called the members of the sequence as numbers, we call them terms. So 2 is a term, 5 is a term, 8 is a term, 11 is a term, 14 is a term. There is another rule, we call it position to term rule, or general term formula, or the nth term formula. To use this rule, you need to label the position of the term. For example, 2 is the first term from the leftmost term. 2 is the first term. 5 is the second term. To save space, I'm going to use the symbol T. T stands for term, and 2 is the position number, and the position number is placed slightly below the line. If you put the position number slightly above the line, it means squared. We don't want that. So, you need to put the position number slightly below the line. 8 is the third number, 11 is the fourth number, 14 is the fifth number, and 17 is the sixth number. 3 dots here mean the sequence goes on forever. So the question is, what is the 25th term? If you are using the term-to-term rule to find the 25th term, it would be tiring. So we need to generate the position-to-term rule or the nth term formula. First, you need to identify the common difference. So between two consecutive terms, you need to find the common difference. T is the common difference. And then this is the formula. Tn is for the nth term, and then T1 is the first term. N is the position number. Subtract 1 from the n, and then multiply by d. Where is this formula coming from? Where? This formula is coming from the understanding that to find the next term, you need to multiply the d and then add to the first term. Why you need to subtract 1 from the position number? Because the common difference is added at the second term, not at the first term. That's why we don't need to add the common difference to the first term. That's why. For example, to find the second term, you need to add 1 times d to the first term. To find the third term, you need to add 2 times d to the first term. To find the fourth term, you need to add 3 times d to the first term. To find the fifth term, you need to add 4 times d to the first term. To find the sixth term, you need to add 5 times d to the first term. That's where this formula comes from. Here's another formula with different symbols like this one. They are the same. The nth term is the un and the first term is a. They are the same, but I'm going to use this one. Okay? So let's solve the question. The 25th term, using the formula, we're going to replace the n with 25, and then the first term is 2, and then the position number is 25 minus 1 times 3. According to the order of operation, you need to solve the brackets first. It means 25 minus 1, 24, and then multiply by 3. After multiplication, the last one is addition. So the 25th term of this sequence is 74. This is an example of an arithmetic sequence in ascending order. Next, what is the 20th term? Take a look at the sequence. The sequence is in a descending order. And to check whether this is an arithmetic sequence or not, we need to find the common difference. See, between two consecutive terms, there is a common difference, -4. The term-to-term rule for this sequence is to subtract 4. To find the 20th term, we need to use the formula, the nth term formula, and then replace the value of n. So T20 equals, the first term is 15, the n is 20 minus 1 times -4. You need to solve the bracket first, so after solve the bracket, 20 minus 1, we solve the multiplication and then solve the addition and subtraction. So the 20th term for this sequence is -61. This is an example of an arithmetic sequence with descending order. Next, how to find the nth term. You're not going to find the 25th term, you're not going to find the 20th term, now you're going to find the nth term. See, the sequence here, we can call this sequence as odd numbers, the sequence of odd numbers, because 1, 3, 5, 7, 9 are odd numbers. Okay, and then check the common difference. The common difference is 2. Then you can use the nth term formula for the arithmetic sequence. But no need to replace the n. So keep the n. And then the value of the first term is 1. And then no need to change the n. And then times 2. You need to expand the brackets. So you need to multiply 2 by n and then multiply 2 by -1. After that, rearrange, put the 2n in the front of the constants and then simplify. So the nth term is 2n minus 1. This is the example to find the nth term. Next, about linear function. Why linear function? Because an arithmetic sequence is a linear function. Why? Because when you plot or draw an arithmetic sequence on a graph paper, you'll get a straight line graph because the increase or the decrease of an arithmetic sequence is constant. To explain about function, I'm going to use the previous example, which is the sequence of odd numbers. Okay, the nth term is 2n minus 1. So draw an ellipse and then an ellipse again. I'm using mapping diagram here. So the left side is the input and the right side is the output, the nth term. And then start from the first position, from left to right, draw an arrow. Okay, use the formula 2n minus 1 and then put the value of the n into the formula. You'll get the output 2 times 1 minus 1 equals 1. And then the second position, okay, using the formula to get the output. And then for the third position, the same again, using the formula, draw an arrow from left to right to get the output. This is what a function is. It has an input to get an output. That's why we call it an arithmetic sequence a linear function. Then, inverse of a linear function. Okay, the same example, but now we are going from right to left to find the position number. So we are going to use the inverse of a linear function to find the position number. If previously you are learning about how to find the nth term, now you are going to find the position number. So from right to left, start from D1, take a look at this sequence, 1, the first term is 1, draw an arrow, and what about the formula? If previously from left to right, it means from left, previously you multiply by 2 and then subtract 1. Now from right to left, if previously subtract and now add 1. Add 1, okay, like this. Add 1 to the nth term. And then if previously multiply by 2, now divide by 2. Use this formula and the value of the nth term to find the position number, and so on. So it's the second term. The second term is 3, and then use the formula to find the position number. So 3 plus 1 is 4 divided by 2 equals 2. And then the third term is 5. So use it to find the position number. Okay. That's it for today. For questions, we are going to meet using Zoom meeting. Check your Google Classroom. Thank you for watching. Math lesson with me, Scanny.